Okay, let's talk about something you rely on every single day, probably without even realizing it. It's the silent guardian that secures your passwords, checks your downloads, and yeah, it even powers the entire world of blockchain. We're talking about hashing.
But here's a question that might break your brain a little. Have you ever stopped to think about this? A website says, we don't store your password, but somehow they know when you type it in correctly. How is that even possible? It sounds like a total paradox, right? Well, that's the mystery we're going to solve right now.
The answer to that puzzle is a really brilliant idea that works just like a unique digital fingerprint for any piece of data you can imagine. And that idea, that's hashing.
So what the heck is it? Well, imagine a kind of magic black box. You can feed anything into it, your password, a photo, an entire movie file, doesn't matter. You run it through this special mathematical function inside the box, and what pops out the other side is a unique string of characters. That string is called a hash.
Let's make this real. Check this out. If we take a super simple word, like hello, and we feed it into our hash function, it spits out this long, jumbled up mess of letters and numbers that looks totally random. That jumble right there is the unique digital fingerprint for the word hello.
Now, here's the thing. This process isn't random at all. In fact, its power comes from a few really strict, unbreakable rules. And these rules are what make it so incredibly reliable and secure. Let's break them down.
Okay, rule number 1. Hashing is deterministic. That's a fancy way of saying it's predictable. If you put the word hello into that function 1,000,000 times, you are going to get that exact same hash back 1,000,000 times, every single time. No exceptions. And that consistency is absolutely critical.
Rule number 2 is the real secret sauce for security. It's a one-way street. Think of it like a blender. You can toss some fruit in and get a smoothie out. But there is no way you can take that smoothie and turn it back into the original whole pieces of fruit. It's impossible. And it's the same with hashing. You can't reverse engineer the hash to figure out what the original input was.
And get this. This is what's called the Avalanche effect. Look closely here. The only difference between these two inputs is one single capital letter, a lowercase h versus an uppercase h. But look at the hashes they produce. They are completely, wildly different. It's not like just one character changed. The whole thing is scrambled into something new. A tiny, tiny change in the input causes a massive avalanche of change in the output.
And finally, the third rule, the output is always a fixed length. This is kind of mind-blowing. It doesn't matter if your input is the word hello or the entire text of every book in the Library of Congress, the hash that pops out the other side will always be the exact same size. This makes the whole system super efficient.
All right, so now that we know the rules of the game, let's circle back to our original question. How does all this solve that password mystery? And where else is this awesome tool working behind the scenes in your life?
Here's the play-by-play. When you create an account and pick a password, the website doesn't store myawesomepassword123. Nope, it runs your password through a hash function and stores that resulting hash. Then, when you come back to log in, you type your password, the system hashes it again on the spot, and then it just compares the two hashes. If they're a perfect match, boom, you're in.
And that is the whole point. This is why it's so secure, because even if a team of hackers breaks in and steals the entire user database, they don't get your password. They just get a long list of this unreadable, scrambled gibberish. And remember rule number 2? It's a one-way street. They can't turn those hashes back into your passwords. That is how your secrets stay safe.
And believe me, this isn't just for passwords. Hashing is the fundamental backbone of trust all over the digital world. It's used to secure every single blockchain transaction. It's how you know that huge file you just downloaded is the real deal and hasn't been tampered with. It's used for digital signatures, for making databases super fast. It is truly everywhere.
Now, as you can imagine, as technology gets better, hackers get smarter. So just using a basic hash for something as important as a password isn't quite enough anymore. The good guys have had to add a couple of extra clever layers of protection to stay ahead of the game.
First up is something called salting. All this means is that before your password gets hashed, the system adds a unique, random piece of data to it. It's like adding a secret ingredient. This is great because it means that even if you and I have the exact same password, our stored hashes will be totally different. It also stops hackers from using pre-made lists of common password hashes. Then, there are slow hashing algorithms. This sounds weird, but they're intentionally designed to be slow and resource-hungry. This makes it incredibly expensive and time-consuming for an attacker who's trying to guess billions of passwords a second.
And yeah, not all hash functions are created equal. You have to use the right tool for the job.
An algorithm like SHA-256 is the gold standard for things like blockchain. It's fast and super secure. For passwords today, a slow algorithm like Argon-2 is what's recommended. But then you have older ones, like MD5. For a long time it was great, but now it's considered broken. Computers are so powerful that it's become too easy to find two different files that produce the exact same MD5 hash, which makes it useless for security.
So when you boil it all down, it's pretty clear that hashing isn't just some clever computer science trick. It's a fundamental building block of our digital world. It's the foundation of trust. It lets us prove that something is authentic without ever having to reveal the original secret. You know, this quote from the material we've been looking at just nails it. Hashing is a one-way, irreversible function that produces a fixed-sized digital fingerprint. That's it. That's the whole concept in a nutshell. And that fingerprint is the key to so much of what we do online.
And that really leaves us with one final thought. We've seen how this idea has totally transformed security for our passwords, for finance, and for our data. So the real question is, in a world that's becoming more and more about data every single day, what else can we protect? What else can we secure with this simple but incredibly powerful idea of a digital fingerprint?